something weird. When we lived in the country, they just ran around outside. My mom was allergic to them, but they would get mice or snakes or birds, and they wouldn't just kill them and leave them wherever they killed them. They would bring them to the doorstep because they like were so proud. They like wanted you to see like their catch. So yes, I've seen some of that too. So anyway, the kittens will make their debut when they are healthy and ready to be in. Let me do this as a... Nope. I wanted to show off some artwork first. Let's take a look at some cells that people have turned in. I told you if you would draw a cell for me, I would show it off in class. So you ready? Here is the first one. It is loading. I might as well get this other one loading too. This is Gracie's cell. So let's tell her how awesome her cell is. Look at that. Is that not amazing? 3-dimensional and all. Tell Gracie how amazing that is. I mean, seriously. This is not part of the cell project. This was when we did the cell lesson. And she sent me this. And I have just been so blown away. It is awesome. The nuclear membrane. I mean, she's got everything labeled in there so nicely, 3-dimensionally drawn. She knocked my socks off. All right. Darian did an awesome one too. Let's look at Darian's. Oh, I need to flip it here. Sure. But look at like this one's color. There's different things that make each one of them just amazing and awesome on their own. But look at this. Tell me how awesome that is. Amazing. Yes. Tell Darian how amazing that is. Everyone send some love in chat. Yeah, the smooth coloring, the details on the
what? Okay, is that how good it is? It's the ruddy egg, steak, and stop. That's kidding me right now.
I know. It's awesome. So impressive.
Steak.
I love it. Wonderful. Well, you guys, thank you so much for doing that. They were like awesome examples. Tell me right now what passive transport is. This is what we talked about yesterday. What is passive transport? Can I have a student leader help me lead this review? You don't have to tell me everything, but act like me, take things from chat, and maybe have someone do a drawing for us. Would somebody help lead? You don't have to know the answers. You can do it. Gracie's gonna do it. All right, Gracie, lead this little review from yesterday. And like I said, this isn't all on you. This is us as a class. We're pulling this together.
Alrighty. Firstly, can I be heard?
Yes, we can hear you.
Okay, good. All right, I do not know the answer to this myself, so this will definitely be interesting. Passive transport movement of what is massive transport?
I saw someone typing in chat earlier that
I'm sorry, I have no idea what the answer is, so I'm calling.
No, they're gonna help you. What is the movement? What are we talking about? The movement of, guys? Almost, Jenna. Movement of, it starts with M.
Oh, someone. Oh. I see someone's answer in
Yes. Yep, Sam, Cassie, you've got it.
I do see what you're talking about. Someone, I believe Tabby is the one that, oh my gosh, no, I don't want. Good job, everybody. Sorry, I have no idea what I'm doing. I'm
Woo, you're doing a great job. I love it.
not afraid to admit that.
No. So this is good. This is perfect. I love this. Stay on mic with me. So it's the movement of molecules. Good.
Hold on 1 second, let me go ahead.
So that's just the moving of non-living things in and out of our cell membrane.
Do I type the movement of molecules in the little space?
That would be perfect. And then, Gracie, you want to ask somebody to do a drawing of it? Does anybody want to do a drawing of it? What does it look like? Because it's the movement of molecules, but it's from a very specific way. You got this.
Sorry, I'm trying to keep my mic on and stuff for some reason. It's like, okay, you have 5 seconds to talk. Alrighty. The passive transport, aka the movement of molecules on the board. Anybody? Ooh, looky there. I'm gonna use the pointer real quick. Look at that. That's adorable too. I love it all. You guys are doing a really good job. Ooh, it's so good too.
Yes, perfect. Can someone explain what's going on in this diagram? You're doing it so right. And this is like what you can say to him, Gracie, is like, this is a cool diagram. Can somebody tell me what it is and what it means?
Alrighty. This right here, I really like this. I like all the examples, but I feel like this one gives a really good visual. I mean, they all do, but you know what I mean. Would someone like to tell me or the class what this represents?
Yeah, you're
Great
right.
time
What
on
it
the screen.
means, what it's about.
All right. Hey, great job, everybody. Ooh. Everyone's putting really good answers in the chat. Moving from higher concentration to area of low concentration. I believe that that is the correct answer, yes?
Yeah, you're right. Yep. And that's perfect. Will you guys all tell Gracie how amazing she did? Seriously, the more we can have you guys lead the class and the less of me, the better, in my opinion, because you guys like to hear from each other, and you're going to learn differently from each other than you learn just from me. So thank you, Gracie, for taking a risk and doing something that you weren't sure you knew, which is even more brave in my opinion, because it's like, if you know the answer, you feel confident, right? You're like, oh, I got this. But when you don't, you're like, ugh. I don't understand that, James. What does that mean? Oh, because it's working this week. Like she paid, and so it's functional this week. Sorry. I get it. I'm sorry. I was like, I don't understand. That's okay. That's okay. I just got your message in private chat, guys. I'm sorry. All right. Let's move on then from passive transport and look at something the same but different, right? We're going to do that today. Something that is the same but is a tad different. So today we are going to look at something that is called active transport. Active transport. Who wants to read the rest of the goals for the day? All right. So we'll have Draven do the first two. We'll have Lizzie do the second one, and then Macy and Sam, keep your hands up, and on the next slides you can. Sorry, there's a fruit fly. You can read on the next slides. Sound good? Awesome. All right, so take it away, Draven. You can do these first two after I, or you can do what is active transport too, and then Lizzie, you can read this longer one.
All right. What is exocytosis? Give me an example. What is endocytosis? Give me an example.
Active transport is both facilitated diffusion and facilitated diffusion. Both involve what in the cell membrane to help move molecules across the membrane.
Perfect. So good. So we've got some weird words today, like normal. Let's spend some time looking at this. Yes, amazing job, all my readers. Let's look at the words exocytosis and endocytosis, and let's do some dissections. Let's do some dissections. Where would we dissect the word exocytosis and endocytosis? Yes, Jenna? Right? Jenna said right here, exo and cytosis. Good job. Yes, Gracie. Yes, Jenna. Yes, yes, yes. Endocytosis. All right. Now, we're going to pretend that you just got to a test, and you're taking a test and you see those words. We're doing this in our brains. Okay? We're going to slice these words in our brains and we're going to guess. So what would we guess that exo, the prefix, means? Ooh, good, Draven. Exo, outside, exit. Good, out. What about endo? Endo. Enter. Into. Inside. All of these are good. And guys, all of these are right. Okay, so we know that it has to do with something with exit and enter. What could we guess about cytosis? It's a less familiar word, probably. What about cytosis? Is there anything? These aren't all bad thoughts. Let's just keep processing. Think about where we're at. We're talking about cells. We're in biology. What starts with cyto? In cell biology? Ooh, cyst. It's a good idea. Cells morphing. Ooh, Tabby. Ding, 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 ding. Cytoplasm. Cytoplasm, what is the cytoplasm? Who can tell me? It's part of the cell, right? You got this. Kind of like the cell wall. All right, if we look here at this drawing, all this blue is the cytoplasm. It's a jelly-like substance, remember? It's like the donut cream filling. Right? It's what holds the organelles still so that it's not like a magic 8-ball that we shake, and when the cell has movement, the organelles aren't bouncing off the walls, right? Jenna, that's perfect. Yeah, it keeps stuff in place. It's the middle of the cell. It's the interior of the cell is where the cytoplasm is. So if you take cyto and associate it with cytoplasm, what could we say with what we just know about exocytosis? Exo meaning exit. Cytosis means cytoplasm. Outside the cytoplasm. What about exit cytoplasm? Right? Exit cytoplasm. Right? I mean, those are the two words that we just can't put. And if we just put them together, exit cytoplasm. What about endocytosis? Enter, and then what? Enter cytoplasm. Okay, what you guys just did today, why are we doing this? Why are we taking time? Why don't you just teach us, Mrs. Rittenhouse? You know what it is. This is annoying. Like, just tell me. Why are we spending the time doing this right now? I'm going to tell you. Yes, 100% to get you involved. 100% this is going to stick in your brains better because you figured it out. I didn't just tell you. But guess what? You all are going to be taking a test at the end of this course in the spring. And there are going to be vocabulary words that you don't remember. There probably are. I mean, I'm just going to be honest. You're going to come across words that you don't remember. And what I'm trying to teach you right now, and every time we do this, is that you don't have to have it all memorized. Or when you do forget something, guess what? It's not hopeless. This is test prep right here. I am teaching you how to dissect those words so that you guys can say, all right, this is a funky word, but I can handle this. Let's just cut it up into pieces, and I want to figure out what pieces of that mean. All right? You all told me exit and enter, and it didn't take us that long. And the more we study cells, the more the cytoplasm might come to your mind. You all told me the exit cytoplasm, enter cytoplasm, and that's exactly what we're going to look at today, is how things come in and out of the cell through processes called endocytosis and exocytosis. All right? So I want you to feel like you're flexing right now. I want you to feel strong and confident that when you come across big words, yep, that is right, Jenna. That when you come across big words like that, you don't have to freak out. That you're like, guess what? I'm actually smarter than I sometimes feel like I am because I can do this. I'm going to break this apart, dissect it like Mrs. Rittenhouse taught me, and I'm going to feel pretty good about going into any test because I may not have every word memorized, but I know how to break things down into chunks and figure it out. All right. Awesome. So, Macy, will you read to me about what active transport is?
Moves molecules from low concentration to high concentration and requires energy.
Perfect. So what is different between active transport and passive transport? Yes, great job. High five. That's what that was. All right, what's the difference? Yes, so good. Sam, will you circle that? Yes, two things. Somebody circle that it requires energy. Perfect. That's the biggest difference. All right. Instead of going downhill like the skier yesterday, we see this guy pushing a boulder uphill. Why? Why does it require energy? What is different about the molecules? Are they doing what they want to do? Yes. Someone highlighted against. Those molecules. So yesterday we talked about that crowded hotel room. Okay. I put you all in a very small hotel room. All right. You were all over here. I stuck you all in this room and made you stay here. But then I opened the door and I said, okay, never mind. I'm opening up another room over here. You can be in either one of these rooms. And let's show you all. Use your pointers. We did this yesterday and I thought it was so good. Everybody put your pointers in the high concentration room. What happened when I opened up the other room? What did some of you do? Yes, you immediately started moving to the room that had the less amount of people. All right. So what actually happens is, can I have almost all of you come back to the high concentration room? Can I have like one or two of you stay on the low? There, that's perfect. So what happens in active transport is that instead of everyone going to the low room, I'm trying to get these people over here, these arrows that have all this room to themselves. I'm trying to move them this way into the chaos, into the crowd. I'm saying, hey guys, I know you're living over here and you've got your own space in your room or whatever, but I need you to come over here. All right. And you all are like, heck to the no. Like, you're going to have to like give me some kind of reward. And I'm like, oh, I'll give you $10. And you're like, no way. I'll give you $20. And you're like, no way. Right. I'm having to work to get you to move. Does that make sense to you? The molecules don't want to move into high concentration. They don't want to move into the crowd. That's uncomfortable. They don't like it. All right. So in active transport, the cell has to say, ready or not, you're going to go. And the cell has to actually use energy to move those molecules from low to high. Just like if I right now pulled Mila in here, she just went out with cat food. I think she's feeding the kittens. If I asked Mila right now to go grab a bag of chips and watch TV, what do you think she would say? Sure. But if I said, hey, Mila, you're going to do 5 hours of Class Connects right now. And she does less being younger. She does 3 hours of Class Connects. But if let's say 6, let's say I doubled it. You're going to do 6 hours of Class Connects back to back. And while you do that, I want you to fold laundry. What do you think should like? Yeah, right? Like outrage. Right? Or if I said, okay, today is family day. It's not, but on Friday. If I said, on your day off, Mila, we are going to use the whole day and you're going to clean this whole house by yourself. I want you to dust, do the dishes, laundry, sweep, mop, scrub the toilets. Like, no. She's going to like revolt, right? She's got her normal chores that she does, but like to do all of that and on her day off, she'd be like, what in the world? Right? I might have to constantly be watching her to keep her on task, to keep her working. Or I would have to motivate her by giving her money, right? It's going to require money or work on my behalf to keep her going. This is active transport, right? Yes, you better pay her good, Cinderella. I know, right? That's how she would feel. And so that is what I want you to think of when you think of active transport. So we have to have ways of doing that. So like, what could I do to help her get those things done? Well, I could pay her, right? Might have to pay her a lot of money. I could maybe bribe her with doing something really, really fun, right? And be like, oh man, if you can do this, you can have 5 friends over for a sleepover or something crazy, right? That we don't usually do. These are the bribes right here. All right. Endocytosis, exocytosis, and the sodium pump, they are the ways that our cell moves things that don't want to move. All right. This says, all right, you're not going to do it. I'm going to make sure this happens. Right. And this is how the cell does it. Let's look at these. I like to think of it as cellular eating. Do y'all know SpongeBob? All right, this is cellular eating. Sam, do you want to read us what endocytosis is? Endocytosis.
I'm stealing your.
Mine?
I can hear you.
Give me 1 second. I'm gonna switch over to my dad's headphones.
You're fine. I know we can hear.
Can you guys hear me?
We can.
You said endocytosis.
Yes, if you don't mind.
Ingesting large amounts of material into the cell.
Yes. So when our cells want massive amounts of something, I like to think about this as eating, it literally forms like a little pod or pocket in the cell, and it literally kind of just engulfs it. Little pockets that just kind of be like, whoop, I want you, you're mine. Almost kind of like a hug, right? That brings it into the cell. All right, this is literally endocytosis. It's bringing them into the cytoplasm. That's what's happening. Okay, all these molecules are outside the cell. The cell is like, you look good to me, get in my belly. Hugs them as much as it can, like hungry hippos, right? And gets the marbles and literally brings them into the cytoplasm. I mean, it's just that easy. I know that it looks maybe oversimplified, but that's how it works. Does that make sense? I want you to think hungry hippos. That is endocytosis. Bringing bulk amount of molecules into the cell by using a pocket, engulfing it, and bringing it in. Yeah. Endo is like eating. I want you to think about it, though. We're going to come make another analogy in a minute. What would exo be? Liz, or Sam, you want to read exo, and Lizzie, I'll have you be on the next slide.
Transporting materials out of the.
Yes. So just like endo is like bringing them in, is like eating. What bodily processes are exocytosis? Do it. Put it in chat. Somebody do it. Vomit. Pooping. Sneezing. Right? Going to the restroom. Right? Is flushing them out. Taking things out. It's the exact opposite. We have little molecules in our cells that their job is kind of like a police car. They patrol the cytoplasm and they're like, you don't look good to me. There's too much of you, or you're a foreign something or other that's not supposed to be in there, a foreign molecule that's not supposed to be in our cell, and our policeman engulfs it and then brings it to the edge of the cytoplasm and releases it, gets it out of there, right? So this is stuff that there's either too much of or that isn't supposed to be in there, okay? This is exocytosis. Enter is like eating. Exocytosis is like removing, like I'm done. Please tell me this is easier than you thought this was. Literally. Endocytosis is like hungry hippos. All right. Exocytosis is like the policeman running around your cell, finding garbage, finding bacteria, finding things that shouldn't be in your cell and saying, oh, I don't need you in here, and taking it to the cell membrane, the border of the cell, and getting it out, pushing it out. Both endocytosis and exocytosis are active transport, which means our cells in our body have to use energy to do it. Okay? If you are a methase, we have very few, but if you are a methase, what I want you to do is I want you to make these drawings today. And I want you to label them. Endocytosis, how things enter the cell using energy. And draw this. So snip it right now. Ooh, Jenna, you are transitioning us perfectly. We're coming. We're getting there. Jenna's saying, okay, well, does this have to go through a protein? No. Endocytosis and exocytosis do not require a protein, but the next thing we're going to look at does. Okay? We're going to hit on it really quick before we have to leave. All right, this is what requires protein, and that is what we call the sodium potassium pump. All right, Lizzie, can you read to us about the sodium potassium pump? And then even maybe Lizzie read through the first two steps, and then Gracie lead through the second two steps of the sodium potassium.
Okay. The sodium potassium pump relies on membrane-bound proteins and ATP energy. Let me zoom in real quick. The sodium potassium pump binds 3 sodium ions and a molecule of ATP. The splitting of ATP provides energy to change the shape of the channel. The sodium ions are driven through the channel. You're muted.
Okay, apparently. Okay. Apparently it's not wanting. There, zoom in real quick. Released into the outside of the membrane in the new shape of the channel allows 2 potassium ions to bind. Release of the phosphate allows the channel to revert to its original form, releasing the potassium ions inside of the membrane. Thank you.
Your mic is, Mrs. Rittenhouse, your mic is still off. We cannot hear you.
I'm so sorry. Thank you. Have you guys ever seen when you walk into grocery stores, those little machines that are out there, and you can put like 2 or 3 quarters in, and then you spin it and something comes out? Like it's a gumball, or it's a toy, or a sticky hand, or a fidget. Yes. This kind of reminds me of the sodium potassium pump. It's kind of like a vending machine of the cell, and it's saying you can come in, but you must pay, kind of like a toll road, right? Like I need you, you can come in, but you must come in here, right? Like you have the pass lane for like the cars that have the tollway pass, and then you have the people that are going to throw your little coins into the little collector. This is what happens in the sodium potassium pump. It receives things, but it also has to have that ATP molecule on there. They pluck off that ATP, say thank you for your money, right? And then those molecules are allowed in. I want you to type this in chat, and we're about done. Break bonds equals energy released. Anytime that we break bonds, those covalent bonds, those hydrogen bonds, those ionic bonds, anytime we break bonds, energy is released. So in cellular things, we make molecules to break molecules. Everyone say that. Whether it's out loud at your house or on the mic or in the chat, we make molecules to break molecules. Yeah, we make molecules to break molecules. All at different times. We make them at certain times so that we can take them and that we can break them. And we're going to learn a ton more about that as we continue out through this school year. But that starts here, okay? Active transport. It is going to break that ATP molecule off as an energy payment to bring molecules in against the gradient. Endocytosis. It's going to bring things in by the cytoplasm is literally moving, right? To engulf and bring in. Exocytosis is actually moving molecules to the membrane and pushing them out. To bring in or to push out requires energy, okay? These are ways that we bring molecules in and out of our cells constantly, okay? To keep your cells alive. So let's reevaluate before we leave. Active transport, could you tell me what it is? Give me a yes or a no. Good. Exocytosis. Exocytosis. Do you know what it is? Yes or no? Do we feel like we can do it? It's the exit of the cytoplasm. We push out cells. What about endocytosis? Yes. So 5 ways. Yes. But they won't say, like, there won't be a question, Jenna, that says, what are the 5 ways that something can enter or exit a cell? They'll ask you to explain, like, what passive transport is or what active transport is. And they'll expect you to know that endo and exocytosis and that sodium potassium pump are ways of active transport. Okay. Same thing with osmosis, right? We talked about that yesterday. It's the movement of water molecules from high to low. It's still passive transport, but it's water specifically. And osmosis, we're looking directly at water, okay? Again, you can come here, you can participate, you can feel great, but if you don't do something to take action, an action step daily, you're not going to put this stuff in your brain. So get your markers out, get your paper out, get your index cards out, get your reading glasses on and read through this lesson. It's going to be different for every single one of us, but I want you to commit to doing something today. Maybe you're going to make a diagram of what the difference is between active and passive transport. Maybe you're going to go back to yesterday and tell me the difference between isotonic, hypertonic, leaves, hypotonic, comes in, what those solutions look like. I don't know. Everybody needs to do something different based on what they feel less confident in. Okay. Awesome. I know it's late. You have places to go. This was a great lesson, though. Thank you all for being here. I will see you later. I'll see you tomorrow, okay? Have a great Tuesday. Thank you. Thanks, Addison. See you guys. I'll see you tomorrow. Thank you. I appreciate that. You too.